Hi everybody, this is the week 3 quiz and homework help. So should help you a little bit with the probability, the math portion of the homework and the quiz. Maybe not all of it, but a good portion of just the math and the math portion of the quiz and some of the math in the homework section, in the assignment section. So first I want to go over, oh, by the way, I really highly recommend when watching this video is pull out the week 3 formula sheet, the chapter 5 formula sheet that I have. I posted it in the week 3 area. And just to show that, it should be popping up here. Give me a second. Okay, maybe it's not. Give me another second. There we go. So this is the week 3 formula sheet, and so you can print that out or download it from the week 3 area. It's pretty much all the formulas in chapter 5. Everything in chapter 5, the formulas that you'll need to do the probability assignments as far as the math portion goes. Okay, so let's get this show going. The first problem, it says, if an experiment consists of 3 outcomes, an experiment has 3 outcomes, and you have the probability of the first outcome is 0.15. The probability of the third outcome is 0.40. What is the probability of the third outcome? Well, if you look at that formula sheet that I had down near the bottom, it says the sum of the probabilities equals 1. The sum of the probabilities, when you add them up, however many there are, and in this case there's going to be 3. 1, 2, 3. The sum of the probabilities is going to equal 1. Okay. So if it equals 1, we have 0.15, 0.40, 0.15 plus 0.40 equals 0.55. So how much more do we need to equal 1? Well, you could just take 1 minus 0.55, and the answer is 0.45. Okay, 0.45. That is the probability of 3. If I add up 0.15, 0.40, and 0.45, they all add up to 1. So that's the first one. Next problem. If A and B are mutually exclusive events, with the probability of A equals 0.37, then what does the probability of B equal? Well, on the formula sheet, you might want to look for something that says mutually exclusive. So there it says if 2 things are mutually exclusive, that means they have nothing in common between them. In other words, their probabilities are going to add up to 1. Very similar to the last problem we had. So these are mutually exclusive. We have a probability of A. We have a probability of B. They're mutually exclusive. They don't add up, or they don't have anything in common. So the probability of B is going to be pretty much 1 minus the probability of A. So 1 minus 0.37 equals 0.63. Okay. Mutually exclusive means you have two sets, A and B, and they have nothing in common. There is nothing that overlaps each set, nothing that's in both. Problem 3. If the probability of A is 0.65, the probability of B is 0.85, and the probability of A or B equals 0.80, then find the probability of A and B. So obviously A and B are not mutually exclusive because we're trying to find A and B, which is something that's in common with both. I'm going to my formula sheet, and if you go to your formula sheet, look up the addition rule. It pretty much has everything we're talking about. When you're looking for a formula, you're looking for a formula that has everything that we're talking about here. So look at the addition rule in the formula. It says the probability of A or B, maybe I should do a big A, equals the probability of A plus the probability of B minus the probability of A and B. Okay, so we have pretty much everything here. Probability of A or B, if you look at it, is 0.8. 0.80. The probability of A is 0.65. The probability of B is 0.85 minus the probability of A and B. That's what we're trying to find. So this is just a math problem. We have to find out these two added and then this one subtracted needs to equal 0.8. So 0.65 plus 0.85 equals 1.50. Right? Try your calculator. 0.65. 0.65 plus 0.85, and I get 1.50. So 1.50 minus something, we don't know what, 1.50 minus 0.8 equals what? So I need to find out what that equal sign is. There's lots of ways you can do the algebraic method by subtracting minus 150 to both sides, or you can just start and you get negative 70. So if you look at it, what goes into this spot? The answer is 70. 150 minus 70 is 80. But I want to make sure you know how to do this. You could go through trial and error if you want. You could put 50 in there. 1.50 minus 50, you still have 1, but we need 8, right? So you can put 0.60 in there. 1.50 minus 0.6 is 0.9. No. Try to put 0.7 in there. 1.50 minus 0.7 is 0.8. So the correct answer is 0.7. I hope that makes sense. 0.70. And check your work. 1.5 minus 0.7 equals 0.8. So the probability of A and B is 0.70. So we're just adding those together, and we're trying to figure out what goes in here. What can be subtracted from this to equal this? And it doesn't matter if they gave you A, B, and A and B, and you had to find A or B. You just do the same thing. Or if they gave you this, this, and this to find this, you would be doing the same thing. You say when you find an answer, make sure you plug it back in and verify that it's correct. Let's try the next one. If probability of A is 0.40, if the probability of B is 0.55, probability of A and B is 0.35, then what is the probability of A given B? So that slash means given. A given B. It's a conditional probability. So if you go to your formula sheet, we want to find the probability of A given B and see if we can do anything with that. So I'm going to look at my formula sheet, and in the formula sheet, in the conditional probability, it says probability of A given B is the probability of A and B over the probability of B. You see, it says the probability of A given B equals the probability of A and B. It's supposed to be and over the probability of B. So that's from my formula sheet, the conditional probability. And do you see how we have the probability of A and B right here? And we have the probability of B. A, this number here, A, we don't need it. It's not part of it. Don't need to do it. So probability of A and B is 0.35, the top of the fraction. The bottom of the fraction is the probability of B, 0.55. Put that in your calculator, 0.35. 0.35 divided by 0.55, and I get 0.636. Okay, so use that formula sheet if for everything, or you can use the book. Go through the book, and all the formulas are there. The same formulas are there in the book. All right, problem 5. This is a problem in the book. If you go to page 76, which I'm going to do right now. And we're going to do 5.7. Page 76, 5.7. So I kind of put the table here a little bit. It basically says the following table lists the probabilities of unemployed females and males and their educational attainment. So all of these people are unemployed. So that's the key. We know all of these people are unemployed, and this is their education. This first category is females. This category is males. So if you look in your book, it should look very similar unless I wrote something down wrong. And by the way, 5.7 is not part of your homework. That's why I'm doing it. I think it will help you, like for problem 5.6 and 5.9. It'll help you with the tables, okay? It'll help you with the tables. So problem 5.7a says, if one unemployed person is selected at random, all of these people, by the way, all of these people are unemployed that you see right here. This entire chart is everybody is unemployed. So if one of these people unemployed is, we're doing 5.7a, is selected at random, what is the probability that he or she did not finish high school? So which people did not finish high school? This is the less than high school row. So this is the percentage of females who did not finish high school. This is the percentage of males who did not finish high school. So what percentage of the part A is asking, what percentage of these people who did not finish high school, what is the probability of being selected? You know, if you're unemployed and did not finish high school, well, just add these two probabilities together. 0.077 plus 0.110 and 0.187. So the question was, again, if one unemployed person is selected at random, what is the probability that he or she did not finish high school? 0.187 is the probability that a person is in this category is unemployed and did not finish high school. Now, I've got a question. So that's the answer, by the way. But what if they want a percentage? 0.187. But what if they want a percentage? It says, what is the probability? Well, the probability is a decimal. Just to show you, you could change any decimal number to a percentage by multiplying by 100. 0.187 times 100 is 18.7%. So out of all these people, if I pick somebody at random, 18.7%, if I pick one person at random, they have an 18.7% chance of not having a high school diploma. Because 18.7% of these people do not have a high school diploma. Okay, that was part A. I hope that made sense. Part B, it says, if an unemployed female is selected at random, what is the probability that she has a college degree? So if an unemployed female is selected at random, so first of all, these were the females. These were the males. So if an unemployed female is selected at random, so we're only looking at the females. What is the probability that she has a college degree? And right here is the probability that she has a college degree. So what's the answer here? Okay, so if a female is picked, that means we're only focusing on the females. What is the probability that she has a college degree? Well, it's 0.092 of the females, have a college degree, but this 0.92 deals with the entire population, with the females and the males. We want to focus just on the females. So instead of saying over 1 over the entire thing, we want to say just over the females. So I'm going to add up the females. So add up all the percentages of the females. 0.077 plus 0.154 plus 0.141 plus 0.092. Do you see the females make up 0.364 of the population? 0.077. Oh, wait, no it doesn't. That should be a 4. I think I added it wrong. 0.077 plus 0.154 plus 0.141 plus 0.092. and I get 0.464. So, see, this is not over 1. That's not over 1. It's over the females because we're only talking about the females. We're not talking about all the people in this group. So you have to put 0.092 over just the total for the females, 464. So on your calculator, the correct answer now is 0.092 divided by 0.464. And if we just pick the females, what's the chance of her having a college degree? 0.198 or 19.8%. So you can't just say this is the answer because this 0.092 is for everything, is the data for everything. But this question is just asking for females only. So we have to concentrate on the females. Do you see if I add up this other column? Let's just add up that other column for a second. 0.110 plus 0.201 plus 0.19 or 129 plus 0.096. Do you see how it adds up to 0.536? These two add up to 1. So in the first problem it says did not finish high school. That's why we could say that over 1. We didn't have to do anything with that first problem because we're talking about the entire situation. So here we're talking about females and college graduates. Well, 0.092 is a college graduate, but just out of the females. So we had to add up the total percentage for the females. So it's 0.092 over 0.464. And the answer was 0.198. I hope that makes sense because we're talking about just the females. It's really important that when you're looking at these tables, you understand what the question's asking. So we've got one more question. Let's see what that says. Don't forget, these are the females. These are the males. The next question's asking, if an unemployed high school graduate is selected at random. So we're just looking, by the way, all of these people are unemployed. But if an unemployed high school graduate, so we're just looking at the high school graduates. You know, just like in the last problem, we were just looking at the females. This time we're just looking at the high school graduates. If an unemployed high school graduate is selected. Let's add those up before I even answer the question. 0.154 plus 0.201. Do you see when you add that up, you get 0.355. So this is the total probability for high school graduates. So the question is asking, if an unemployed high school graduate is selected, what is the probability that he is a male? Male is 0.201. So it's going to be 0.201 over the total of high school graduates. This is the male high school graduates over the total percentage of the high school graduates, which is 0.355. You see, we're concentrating just on the high school graduates. The bottom number is going to be the sum of that column or row. So it's 201, or 0.201. 0.201 divided by 0.355, and I get 0.566. This is the probability, once again, 7C, if you unemployed high school graduate. If you look at just the high school graduates in this column, what's the probability that person's male? 56.6%, 0.566. Take the 0.201 and divide it by the total of the high school graduate, which is 0.355. All right. And the last problem is from page 77, number 14. I'm going to do that one also. It says a chartered financial analyst CFA is designated to earn after they take 3 exams, exam 1, exam 2, and exam 3. So in this problem, exam 1, exam 2, exam 3, it's just showing you how to create a table. In some of the homework problems, you might have to create a table, so that's what I'm going to do here. Exam 1, 2, and 3. And we're doing problem 14. It says the exams are taken in early June. Candidates who pass are eligible to take the exam the next level the following year. The pass rate for level 1, 2, and 3 are 0.57, 0.73, and 0.85 respectively. That means the 0.57 is the first one. 0.73 is the percent pass rate for the second one. And 0.85 is the pass rate for the third one. Suppose that 3,000 people take the level 1, 2,500 take the level 2, and 2,000. So 3,000 people took this exam. I'm going to put take. And I'm going to put here the pass rate, pass. 2,500 took this test. And 2,000 people took this test. Suppose that one student is selected at random. What is the probability that he or she passed the test? So we want to pick one person and find out what's the percent that they pass the test. We already know 57%. Uh-oh, I don't know what just happened there. We already know 57% passed the first test. 73%, 0.73 passed the second test, and 0.85 passed the third test. But we don't know how many people. We know 3,000 people took the test. If 3,000 people take the test and 0.57 pass it, all you have to do is multiply these two together, and it's going to tell you how many people passed the test. 0.57 times 3,000 people who took it. You see, 3,000 people take it, but the pass rate is 0.57. When you multiply those two together, you realize that 1,710 people actually passed the test. Out of 3,000, 1,710 passed it, because 57% had to pass. So we're going to do the same thing here. How many people actually passed test 2? It doesn't tell us. It says 2,500 took it, but how many people passed it? 0.73% times 2,500. And if you look here, 1,825 people passed test 2. And we're going to do the same thing for test 3. 0.85 times 2,000. And I get 1,700 pass the test. So, what's my chances of passing a test? That's what the question is. If we look at question 14, at the bottom it says, what is the probability that he or she passed the exam? We're looking at everybody here, picking one person. What's their chance of passing the test? Well, let's add up all these people. These are all the people who passed it. 1710. So I'm going to add up all these, plus 1825, plus 1700. Do you see 5,235 people passed the test? 5,235 people passed the test. My question to you is, it has to be over the total people. Do you see? They want to know the overall pass rate of everybody who took the test. We know just test 1 was 50%, test 2 was 73%, and test 3 was 85%. But what's the entire pass rate of everybody? Add up all the people who passed it and divide it by the total number of people who took the test. And here's all the people who took the test. 3,000 plus 2,500 plus 2,000. If you add those all up, you get 7,500. Here's the people who took the test. Here's the people who passed the test. So you take the people who passed divided by the people who took it, and that's going to give your overall pass rate. 5,235 divided by 7,500, and you get 0.698. Almost a 70%, 69.8% chance of passing the test. The question is, what is the probability that he or she passed the test? It was 6.698. That is our answer. The total people who passed the test divided by the total people who took the test. You see how these tables will help you. Don't try to answer these questions, these word questions in this chapter 5 without creating a table, especially near the end, 5.3, 513, 515. Create a table and they will help you get through it. Call me if you have any questions. I hope this video helps. There's no Excel this week, so I hope everybody, and there's no discussion during week 3, so I hope we're all doing fine. Everybody should be settled into the course by now.